Hi, everyone. Welcome to the Sense Think Act podcast. I'm the host, Audrow Nash. Today, I speak with Melonee Wise, former CEO of Fetch Robotics and now VP of Robotics Automation at Zebra Technologies. We talk about her experience with Fetch Robotics, the differences and similarities between mobile robots in a factory setting and autonomous cars, and her outlook on the future of robotics. I really enjoyed this interview. First, it was really nice getting to know Melonee, and also I found it very interesting to hear about the different stages that Fetch Robotics went through before being acquired. Specifically, they started as a hardware company building the robots, which only lasted 5 months or so, and then they were a software company, and now Melonee is describing them as a data company. This is very interesting. With that, I hope you enjoy. Hi, Melonee. Would you introduce yourself?
Yeah, I'm Melonee Wise. I'm the former CEO of Fetch Robotics, now the VP of Robotics Automation at Zebra.
Mm-hmm. Would you? So that's really exciting. Would you tell me a bit how Fetch and Zebra are related?
Yeah, so I started Fetch Robotics about 7 years ago, and this week we actually closed on an acquisition of Zebra acquiring Fetch Robotics. And so Zebra Technologies acquired Fetch to create a new robotics automation division, and Fetch makes autonomous mobile robots for the logistics and manufacturing industries.
Mm-hmm. So going into Fetch a bit more, congrats on being acquired. That's so exciting. And you said it was ahead of your timeline, your 10-year, whatever, being
Yeah.
so your it was acquired in 7 years. Would you tell me a bit more about Fetch? So it's for warehouse related robots, but just, I guess, background information on the company.
Yeah. And to be clear, when I said I had a 10-year vision, what I meant is when I first started talking about it, Fetch Robotics to investors, I
Mm-hmm.
kind of I kind of made sure that they were in it for the long haul because robotics is such a hard problem. So I was like, hey, you realize that this is a 10-year problem. It's not like you're gonna get an acquisition like you would in a software company and, pump a couple dollars into it and flip it into an IPO or an acquisition in a couple of years. And
Yep.
so that's there wasn't really like I wasn't like, oh, I'm going to sell the company in 10 years. It was more like,
Yep.
you know, uh, when you go and try and convince people that robotics is something interesting to invest in, you need to help temper their expectations because, um, if you look at the car industry, we've been saying since, I don't know, 27, like 2007, that we're going to have autonomous cars next year. And we've
I
been
know.
saying that every year for the last, you know, 14 years.
That's crazy.
Um, so I, 7 years ago, I started Fetch, and I started the company with three other co-founders, Derek King, Eric Dyer, and Michael Ferguson, and we all worked at Willow Garage together. We were part of the robot development team at Willow Garage. It's a team that basically for about a 2-year period built a lot of different robotic prototypes to look at different industries that were of interest to Willow Garage because about 2 years before it ended, the founder that started Willow kind of said, "Well, what's next? Congratulations, you did open source." Although that's kind of a funny statement to make, but he kind of said, "Congratulations, you did some open source. Now what?" And Steve Cousins at the time said, "Hey, we need to go look at the home and then industrial applications." And it's really funny when you look at the people that worked at Willow Garage and the companies that were then formed by the former employees of Willow Garage. They all kind of reflect the different areas that we investigated in the last 2 years. And we investigated everything from like grocery retail to manufacturing to hotels, for example. Steve went and started Savvy Oak and did hotels. And the guys and I that started Fetch Robotics, we looked at the manufacturing and logistics verticals, and we saw it as an interesting problem to solve. And when you look at that, the reason that was interesting to us is we thought it was a tractable problem. Like most warehouses and most manufacturing facilities are what you might call semi-structured. But there was also a large like dynamic happening in the industry where finding new employees is very hard. And even before the pandemic, there was a large labor shortage
You mean for
in,
factories?
yeah, yeah.
Ah, okay.
Yeah, for factories and warehouses. Before the
Yep.
pandemic, there was about a 600,000 person shortage. So there were 600,000 open jobs
How
that
many
no one was
people in the
filling.
industry overall, would you
I
guess?
don't know that statistic off the top of my head, but I do know before the pandemic um, there were about 6 million jobs available, and the job openings in the manufacturing and logistics industry represented about 10% of all open jobs in the United
Wow,
States.
that's
Yeah.
crazy. Yeah.
And for a long time, the United States was running at a deficit for labor, right? So we had, for a long time, we only had about 5 or 6 million people unemployed, and we only had about we had about 5 or 6 million jobs available. And so it was a close thing. We were running a, what you might call a negative employment rate, where there weren't enough people for all the
For the
jobs.
jobs.
Yeah.
Huh.
And so
That's really
that's,
interesting. I didn't
yeah,
I mean, you hear about robots taking jobs and things like this. In this case, it's the complete opposite.
yeah,
There are not people for that.
yeah.
But we need more people to fill out the roles so that the companies can be more efficient. That's very
Yeah.
interesting.
And I think that's one of the key reasons why over the last couple of decades there's been this strong push for automation, and why you're seeing in a lot of industrialized nations, you're seeing a lot of push to get more and more automation so that they can stay competitive, so that they can grow their GDP, et cetera, et cetera, et cetera. And so that led us to be interested in creating Fetch. And, you
How is
know,
it?
the
So that is the case now, just before COVID. Fetch is 7 years old or so. Was that the case then too? And how has that changed over time?
Yeah, so that trend was very much true before when we started Fetch. There was
Hmm.
just a huge labor gap in the industry, and what's even worse is it's coupled with a turnover rate of about 40%. So
Super high,
yeah,
basically. What kinds of jobs are these? Like, what does a person in these jobs do for their day at work?
yeah. So they can do anything from like packing out a box to walking around in a 110-degree warehouse picking boxes
Duh.
off of a shelf. Yeah,
That's why the
somebody's
turnover is so high.
yeah,
Gosh.
yeah. They can be assembling small parts or machinery. They can be, I mean, our robots are doing the delivery task of someone's job, and that's the other thing that conflates some of the problems is if you look at it when they're looking at automation to offset labor, it's not typically like this robot is going to replace this person 100%. There really isn't the possibility to do that in most cases today. Um, and so we're
Why
as
exactly?
um because if you look at it, there's a lot of tasks that make up your job. Um, so if you look at say let me think, a picker's job. If we look at what a picker does,
And a
where
picker is
they
a person that picks things out of bins and then puts them into boxes, like an Amazon person,
yeah,
an Amazon
that's
worker.
the overall. They fulfill orders from customers, and so there's a lot of parts to their job. So there's the part of the job where they first prepare all the boxes, and then they put them on a cart, and then they push that cart to a location in a warehouse where there's a shelf, and they pull something out of a box and they put it into a box on that cart, and they're like scanning each of those locations to make sure that the thing that they're picking is correct, etc. And they do that through an entire warehouse, and then they come back and they typically offload the boxes from that cart onto an area where either a separate person or that same person packs it out. So they take it from those boxes, confirm that all the items in it are correct, and then get it ready for shipping. And that means putting like paperwork in it and basically shoving it down a line so someone can put a label on it and tape it. But if you look at it, the picking task is very hard. It's not like there's a lot of robots today that can just wander up to a shelf and pull an item out of a box, especially when they're, let's say they're a whole bunch of t-shirts and they're, I don't know, baby onesies, and they're packed in a box, that is probably only meant to hold 50, but there's 500 of them in there.
Yeah. Yeah.
And so it's a pretty complicated task from a robotics standpoint, whether it's manipulation or vision. And so we today can't do all of the task. And so there's some things that we replace completely, like we don't have them walk all that distance. They'll meet the robot or something like that. Or we change the roles, like now if you have a robot that where the person used to configure the cart and put all the boxes on the cart, maybe one person now is just responsible for doing that for every robot, as opposed to that person individually be responsible for their cart. And so the jobs change, what the roles are change, and really it's about taking out the part of their job or the set of tasks that they do that can be done by a robot. And I think that there's good analogs in kind of the technical world. If you look at maybe writers or journalists, they previously had researchers and they had secretaries and they had all these other tools or resources available to them. And now many journalists, their entire job has been reduced down to doing all those things themselves. But now the tool they have instead of a person is Google or some search tool,
engine.
or yeah.
Yeah.
And so I think there's plenty of analogs for kind of this transition from people doing tasks or part of our jobs for us to us now using automated tools.
Yep. So if I understand correctly, basically the shipping process has a whole bunch of different components that must get done on the way.
Yeah.
And what you do is you say, oh, a robot might be very good at this one spot.
Yeah.
And so by adding robots into the system, you free up people from doing that one task.
Yeah.
But it's kind of, if it's not like saying a robot replaces a person, because there are other things that the people can focus more on when the robot frees up that one
Yeah.
that one area with this
Yeah.
kind of thing. So that's why it's like apples to oranges to say one robot in is not one human out kind of
Yeah,
thing.
it typically isn't. I mean,
And there's
and
that
when
gigantic shortage, so you can just
yeah,
shift the people elsewhere
yeah,
in the
that's the
process,
thing.
probably.
Yeah, that's the other thing is when you have such a labor shortage,
Hmm.
you're not displacing anyone. You're just trying to fill in the gaps.
Hmm. Yeah, and make the few people that are there as efficient as possible, so that you can get as much work done as possible.
Yeah,
So
absolutely.
how did you guys find so you mentioned kind of the detailed process of finding or of what occurs in sending out pick and place, this kind of thing, or picking
Mhm.
products out. How did you find the exact part of that where you thought a robot would be a good fit?
Mm. Yeah, I think that, if you look at it, some of the stuff that we did at Willow, it became clear that when you look at manufacturing and logistics, whether it's picking or it's assembling something, there's always a process in which material has to come from some obnoxiously far away part of the facility to another
Yeah.
part. And it became very clear that there was a high transportation cost. And there's
Hmm.
been plenty of studies done for like labor analysis, looking at different jobs like the fulfillment job that I just described or a manufacturing job. And typically walking time or transport represents upwards of 50% of the person's total time.
Huh.
And so that's a very compelling statistic when you're looking at, should I make a mobile transport robot?
It seems like, to me, that seems like almost a simple way of identifying low-hanging fruit that can be solved with robotics things. I'm thinking of like nurses spend a large period of their time commuting from
Yeah.
patient to patient, and then a company, Haloti Robotics, where I did an internship previously, they were saying how they would have caretakers come to people's homes in Norway, and they spent like 60% of their time commuting from home to home. And these seem like really good robotics applications to me. If you can just put a robot in there and have it do the commuting, or have it do away with the commuting
Yeah.
in some way. Okay, so you looked at this and you saw this number six. You said 50% of their time walking,
Yeah.
which is crazy.
Yeah.
So you started there and tried
And
to
we
reduce that
started
with
building
robots.
mobile robots.
Uh-huh.
And then it came down to, now you have a mobile robot, you have a base. Now, what do you have to put on it to make it productive for the application? And if you look at Fetch today, we offer three major platforms of different payload capacities, so 100 kilograms, 500 kilograms, and 1500 kilograms. And then we put tops on it to basically attack the the different problems in the warehouse. So we have, for our small and big robots, we have a cart connect, which allows us to move around carts. We have a roller top accessory, which allows us to interface with conveyor. We have standard shelving. It's kind of boring, but like a shelf with a touch screen on it.
Yep.
Um, Stuff like that. I mean, it really comes down to the accessories for the hardware. I mean, if you look at Fetch and like the vision and what we were trying to build from day one, we started as a hardware company, and as all robotics companies go, you quickly become software companies. I mean, we spent like a
Mhm.
hot 5 seconds as a hardware company. Um, and I mean, you work at Open Robotics, and like the whole
Yep,
business there is software. Um,
entirely.
yeah, and so we spent a large part of our middle years as a software company, and over the last couple of years, we've been transitioning more towards being a data company as well. So,
Wow, that's the next
you know,
level.
yeah. So
Interesting.
building out our data platforms, building out our data capabilities, things like that. But that's still an ongoing process because you have to build a pretty large data lake to do anything. Um,
So I imagine a lot of like interest in cloud robotics at the moment with this. Is this what you mean with the data
yeah,
thing?
well, so if you look at it, if you look at it, the middle years when we were becoming a software company, that's when we built our cloud robotics platform. So all of our robots are actually controlled from the cloud. They have their autonomous units, but if you want to tell them to like go from
All the
point A to point
decision
B,
making,
yeah,
like the lower level control is done on the robot
all the
probably,
safety
but
navigation stuff is done on the robot, but the
mhm.
task level commands like
Yeah.
go here, do this, come from the cloud. And we did that because it makes getting set up on site a lot easier. If you look at like many of these facilities, they're kind of out in the boonies. They don't have good IT support, stuff like that. And if you come along with a very complex thing like a robot, and you're like, oh, by the way, where do we install the server? Um, it kind of adds a lot. So we went all to the cloud. But one of the advantages of that is we also save the robot data, and we're building capabilities on top of that data. So forklift detection, we can tell when forklifts are speeding. We can tell when they get too close to people, things like that. And so those are some of the capabilities that we're starting to build on top of our data platform. But the important thing is you need a lot of training data. You need a lot of real world data to do anything. And I think it's one of the reasons why when people talk about autonomous cars, I don't think they understand the scale and the scope of what we're talking about when they talk about like, oh yeah, it'll just machine learn it. It's like
Yeah, with a
it's like
nice buzzword for that.
sure.
Yeah.
Yeah. Or they'll say like the car has the AI. If I hear AI one more time, like
I know. It's true. I want to go back and talk about the hardware company, but just tying a knot on this for the data company.
Yeah.
And talking about kind of the scope of the challenge for autonomous cars. So you mentioned warehouses, semi-structured environments. It's probably your data is a lot nicer than what you get. Would you just talk a bit about the difference between the data you're getting and the type of data needed for like an autonomous car,
Yeah.
and how difficult that will be,
Yeah.
probably.
So I think the thing is I wouldn't say that the problem we're solving is any less difficult than that of autonomous cars. I would say they have unique idiosyncrasies
What
for the
explicitly is the
problems.
problem you're solving?
So we're basically building autonomous indoor cars for the warehouse.
Yep.
The difference is we don't have weather.
Hmm.
They have weather, but they typically their sensor package costs about $200,000. Our
Yeah.
sensor package costs about $1,800.
Oh, wow.
So there's
So it's
orders
like,
of magnitude difference in the cost and capability of the sensors that we use.
so that becomes a massive difference. Your sensors, is it like a LiDAR and a few cameras or
Yeah,
what?
it's a LiDAR and two cameras.
Okay, you said 1800 and it's like, okay, that's one LiDAR and two cameras. I
Well,
don't know,
that's
some
that's
small
for the
number of
smaller one.
cameras.
The bigger robot has two LiDAR and eight cameras, but I
Yeah,
mean, it's still
still, the
not
order.
a $70,000 Velodyne, you know.
Yeah,
And so there's that. There's one the kind of sensing tools that we have are very different, and so although they have somewhat of a harder problem to solve from weather and some other aspects, they have better budgets and sensing tools and fidelity to deal with some of those environments that we don't. Um, the other thing that's very unique about our environment that's not true for cars is our environments are far more dynamic in some ways. While roads can be very dynamic and things like that, they
construction
have
and things pop
yeah,
up. Yeah.
they have lots of rules of the road, and pedestrians don't just end up in major highways on a regular basis. Whereas if you look at warehouses, there's like main highways, but people walk into them all the time. The other thing that you have to understand is that our vehicles typically go around 1.5 to 2 meters per second. So we're talking like 3 to 4 miles an hour. But some of the vehicles we have to operate around, like forklifts, can go up to 8 or 9 miles an hour or even faster. And so it's a very difficult problem when you are in a scenario in which vehicles around you are going much faster than you. And then there is the forklift problem.
Okay, what's
Um,
that?
so
Sounds ominous.
so cars don't have to deal with this notion of a piece of equipment being around them that
Hmm.
has tines that are very thin, very hard to
That's
detect.
the like probes
Yeah,
of the
yeah,
fork, right?
the forklift, the tines,
The forklift,
and they can
yes.
be at any height at any time.
Hmm.
And so,
Oh, so they're super hard to sense, probably too.
yeah, they're super hard to sense. They can be at any height, and there's a lot of things like we don't cars don't have to deal with a lot of overhanging things. Roads are built such that nothing's going to be hanging in the middle of the road. It's not like that in manufacturing.
With your
So
LiDAR, are you just taking a plane or
yeah,
what are, oh,
yeah,
so that makes it super difficult. So you
yeah,
have
and
to do a
so
lot with computer vision,
yeah, we do.
probably. And
Yeah,
that's challenging because you have to
and
recognize all these different circumstances.
yeah, and so I'm not saying that the autonomous car problem isn't hard. I'm saying it's very hard, but
They're
I think
both hard.
sometimes people tend to look at the problem we're looking at, and it's like, well, it's got to be easier than autonomous cars, and it's like, well, it's not.
Different.
It's different, and there's things that constrain our problem solving and things like that. And then the other thing that is very true is our industry is heavily regulated from a safety perspective, and autonomous cars are not yet. They're not heavily regulated yet. I mean, there's some regulation, but there's no you have to do this test to prove that your autonomous car is safe, et cetera, et cetera. Sorry, I actually need to stop and take this call really quick.
Oh.
Is that okay?
So we were talking about the differences between the data and basically the problem of autonomous cars versus for manufacturing logistics. Um, can you tell me? So a bit more about the data differences from these two
Yeah,
perspectives?
yeah, I will say that from a data perspective, autonomous cars are using a lot more data. That's what makes us a little bit more open to being able to port and move all of our data to the cloud and do like algorithms and some of these things in the cloud, which a car may not have some of the luxury of doing. I mean, that's, I think, one of the big things that's going to happen in the next decade or two is we realize what it's going to take to make the practical deployment of autonomous cars real is the sheer amount of data you need to just store the map of the local area drive, the area that you drive on a daily basis is massive. And what data networks are going to support just that capability? Everyone's going to have, fiber to their house practically to be able to like overnight download the local area updates and things like that. And then if you want to go on a long trip, say from San Jose to Tahoe, I can only imagine what the strategies are going to be
What's
for.
that? Is that like a 4 hour drive?
Yeah, it's a 4.5 hour drive.
Hmm.
The data strategy is going to have to be to do that. The nice thing for warehousing and our robots is it's 1 million square feet. That's about as big as the problem gets. And so we definitely we have we are running into the multiple source problem, and I think right now in the autonomous car space they're still struggling with the single source problem of how do you get just data out of one car. And we're dealing with, okay, the data that we have to move isn't ginormous, but we have 30, 50, 100, 500 robots that we're transmitting data from, and that's a lot of data. And so it's a pipe problem.
Yep. So with autonomous cars, they're just now thinking how to locally do it. So how can I make this one car do drive from one place to another autonomously? And you're going, we have these robots driving around this entire environment. They're all doing some sort of mapping of this environment, like what's maybe there's an obstacle that has
Yeah.
occurred. And so then they all coordinate based on this. They go, oh, that one path is blocked. I'm going to have to go around, and then it reroutes
I mean, we do
everything.
some
Or,
of that, yes, as part of our coordination. We also use peer-to-peer Bluetooth.
huh,
But I was just speaking more from the sheer amount of like loading the data up and then post-processing it.
ah,
If you look at it today, I think most companies, Google, Waymo, all those guys, use quote unquote sneaker net, which is putting a hard drive in a mailbox and sending it in the mail.
oh yeah, sneaker net. That's crazy. The
um,
heart. What do you mean exactly? Where are they doing that? So like,
well, so you say a company has 30 autonomous cars that they're field testing.
mhm.
Um,
Oh, rather than actually putting it on the cloud and sending it and uploading it, they actually
yeah,
just physically mail the device because of bandwidth
yeah.
constraints.
They take out the hard
Ah,
drives and mail the.
that's
I
crazy.
mean,
Sneaker net,
yeah,
because
I
people are
think,
walking it.
yeah, I heard some companies are uploading more than 40 or 50 terabytes a week,
Holy
and
cow.
yeah, it's a lot of data.
Huh. So so from what it sounds like to me, you have a good bit of faith in these machine learning approaches in the long game. So like 10, 20 years from now, for
Mostly,
different, is that what you think? Or, because I mean, data is not terribly important if you're going to do classical approaches, for things, but you're finding in the warehouse setting that it is important to have a lot of data. Just, can you talk a little bit about this?
yeah. I think that there are some types of semantic behaviors that we care about that we need models for. So we need to know what a thing is. Um, and the problem is that there's a lot of variation in the world. And so if you tried to build a classically trained model for every object in your, I guess traversable space, it would be very hard.
And by classically trained, would you talk a bit about what that means?
You have 1,000 images and data examples of, say, a Volkswagen Bug from 1976.
Yeah.
And you put that all into an algorithm and it spits out a model, and it's really good. That one detector is really good at processing Volkswagen bugs.
Hmm.
And so if you were to look at like the most, I guess you might call it asinine way of approaching the problem is you could say, I'm going to build a specific model for every car on the road every year because they change year to year. Um, and I'm then going to spin up parallel detectors for all of these things. Um, and maybe you want to know the car model, maybe you don't, but maybe there is some material reason why you want to know this. Right now, I think they reduce it down to car, truck, or other. But say you want to do this thing, then the problem is you're probably going to have some set of detectors that all say that they found the thing, right? So if you have 1,000 detectors and 15 of them say I found the thing, then you need to put it through another set of detectors and voting system to decide which one of the things that says they found the thing is right.
Yep.
Um,
Or some approach to figure out exactly what is the one you listen to or what's the
yeah,
most likely.
yeah.
Okay.
And so the challenge with that is it takes massive amounts of data, and that's why people are
To
very
build
interested
like
in
1,000 detectors or something like
yeah,
this, because it's that one problem, but there's a lot more and you have to make distinctions between that.
yeah,
Or is it the first model, but just a bunch of times? Because you could probably do that too and then just have a confidence and weight the confidence.
yeah. Those models aren't as good because
Hmm.
so
You
so
want it all
the
in one model, basically.
yeah.
So it learns the discrimination between them.
I think the problem is if you look at it like a good way to think about like our way that we've been doing learning for a long time is for a very long time we built models and systems where we said this is the thing you care about, this is the thing you care about. We kept showing it the thing they cared about from all angles. But if you look at the way people learn, it's a little bit different. We learn this is the thing that you care about, but we also see on a regular basis thousands of examples of this is not the thing you care about.
Interesting. Yeah.
And so but there's a problem of trying to prove the negative when the space of things that you're trying to prove the negative on is infinite, right? Um, and so this is one of the problems with like machine learning in general. And even if you wanted to show this is the thing that you care about, say we wanted to show a phone, right? This is the thing you care about, and specifically this phone. So it's blue, it has some yellow buttons. Um, a person probably only has the tolerance to take 50 pictures, 100 pictures of this phone ad nauseum. Um,
Yeah.
and one of the reasons that convolutional neural nets are so interesting is it allows us to take 100 images and make it into like 10,000 images. Because that's what the purpose of it is it basically allows us to take the pieces of all these things, split them up, put them back together, and use them to train systems. And that's why, so it's a way of artificially creating more data. And it's found that artificial data that we create results in high confidently trained models typically. Now,
Okay.
there's a lot of tuning and a lot of mumbo
Oh
jumbo that
yeah,
goes
bunch
into
of
it. It's kind of a
heuristics for
black
sure.
art, but
Definitely.
at the same time, but a lot of those systems again are only trained
On positive examples.
on positive. And this is in general a bigger problem theoretically with all of robotics is because the negative examples can be very bad. They can have very bad outcomes. Like how do you teach a robot not to hit someone when hitting them could kill a person, right? So not it whether or not training with only positive reinforcement is good.
Yeah.
Sometimes you can't produce negative reinforcement data. And although I have seen work coming out more and more on how you build simulation models to create negative reinforcement data, for example. But
Probably
but
won't get us all the way there because it
yeah,
can overfit the simulator pretty heavily,
yeah, yeah. And
which
so
has
that there's all
historically been the
sort
problem, as far
yeah,
as
there's
I'm
all
aware.
sorts of problems, overfitting,
Hmm.
weird edge cases, things like that.
And and so how this relates. So If I understand correctly how this relates, um, in the autonomous car problem or in the warehouse problem, you are using some sort, so you get all of this data and you train different models on it, and you use that effectively for perception to help
Mhm.
the robot understand the world and what's going around it.
So that
Um,
it knows, say, that a person is a person. And so
yep,
then the robot can exhibit different behaviors appropriate for that person.
yep.
So, for example, the one thing that's the most mature in our navigation stack is robot to robot detection. So we know when something is another robot. Um, and that allows us to implement certain behaviors within the robot that make them more effective. They will one, give priority to other robots based on what those robots are doing. They
Hmm.
will,
Oh,
steer
that's
away
really
from them.
cool.
Yeah,
So it's going, oh, it's a robot, but it's also going, oh, I can understand from the context of what I can sense what this robot is doing, and thus it's higher priority than me,
yeah,
kind of thing.
yeah.
That's interesting. Okay.
And so then that extends into things like a forklift. One of the things we were talking about earlier is forklifts are very difficult.
Mm-hmm.
Well, one of the more difficult scenarios with a forklift is the tines can be all the way up in the air. They can be 15 feet up in the air, well above the robot. And the robot can't see it. Of course it can't. It's very high up in the air.
Mm-hmm.
Um, Now, if you know it's a forklift, you can know not to drive into that area,
Mm-hmm.
even if you can't see what's there. And so that's one of the examples in which if you can know what things are, if you semantically know that this is
A
a
forklift.
person,
You can
a
inform your
forklift,
policy
yes. Yeah,
of don't drive right in the spot where the tongs may come down,
right.
this kind of thing.
Yeah, and that is what the majority of applications for machine learning and autonomous cars are also for, is semantic understanding. This is a ramp, this is a person, this is a crosswalk,
Huh.
this is a stop sign.
Now, there's one thing that I've seen which is interesting to me is ontologies. And ontologies, it's like a map that shows how all of the different parts that you might see in an environment relate to each other. So if I was an autonomous car, it could be like, this is a road, this is a sidewalk. The sidewalk might have a person or a dog on it,
Hmm.
or something like this. So then it'd be like road has a sidewalk, sidewalk has a person, this kind of thing. It's a relationship
Hmm.
between all these. Do you, and this is kind of a manual way to specify all of the different components.
Yeah.
Um, do you guys use ontologies, or
So
is it interesting?
if you look at that, ontologies in our environment aren't as strict, and this is one of the problems I was saying is like there's a shelf, there's a aisleway next to it, but people and everything else can be in it. A box can be in it, trash can be in it, a
Yeah.
person can be in it. So it's a
Hopefully
very
not.
flat ontology. This is the shelf, this is the
Yep.
floor.
Yep.
um,
Gotcha.
yeah, so I think I agree that ontologies can be very, very helpful for creating kind of semantic maps and relationships, but they don't always apply well in our environments,
Because it's
unfortunately.
very complex. Yeah.
Yeah.
Gotcha. Okay. Going back a little bit.
Sorry.
No, it's cool. This is all very interesting. Going back to being a hardware company.
Yeah.
Can you tell me a bit about when you guys started, when you were a hardware company,
Oh yeah,
effectively?
yeah. Yeah, I mean, we were a hardware company for about 5 months.
In the 7 years that have been so
Yeah,
far?
yeah.
That's
Yeah.
crazy.
Because that's when we didn't have any robots. So
You
we,
had to make the robots.
yeah,
Yeah.
we had to make the robots. The good thing is we had a really stellar team of co-founders who all knew a lot about hardware. And it was really funny. I think one of the more kind of interesting experiences for me and I think for a lot of the guys I started the company with is, we while we were at Willow Garage, we probably built 5 or 6 different types of robots together, and we learned a lot of lessons. Sometimes they didn't power on, sometimes they had problems.
Yeah.
Um,
All the things. Yeah.
yeah, all the things. But when we started Fetch, we had so much experience. Like when we built the hardware, when we designed the hardware, we sent it to a shop. It came back from the shop. We put it together. It turned on. It worked fine.
That's
Um,
awesome.
And what was really funny is there were some employees who had been at other robotics companies, who had been at other hardware companies, and like we're like, what do you guys like? This timeline is insane. All of this assumes that the hardware is going to turn on and work and not catch on fire. And we
Yeah.
were like, well, first, it will never catch on fire. We're not that bad. But
Yeah.
second, it'll be fine. And it was an interesting thing because I think one of the things that I had developed is a somewhat like what you might call robotics amnesia, where I kind of started forgetting that hardware could ever really be kind of shitty.
Mm,
And
so funny.
so like it
Well,
was
that's a nice position to be in when you're realizing
yeah,
hard, like you're like, oh, I'm surprised that this didn't work because
yeah,
everything has just been working.
yeah. And so it was definitely an interesting juxtaposition as the four co-founders were kind of like, oh, we got this. This isn't going to be a problem. And then some
Hmm.
of the new employees that we had hired early on were kind of like,
Are you
I've
sure?
seen this rodeo before, and hardware is never this smooth. Um, so it
Huh.
was it was cool. But yeah, we
Okay.
were a hardware company for a very short amount of time early on. We
And
then
then,
eventually cycled back, and when we built the bigger robots, we became a hardware company briefly again.
hmm.
But that part of the company became a hardware company. It
Yep.
wasn't like everyone there full time was just doing hardware.
Yeah. So then, how did you go about, so like the manufacturing process and everything for like, so once you worked out the designs, how do you go into actually making
Hmm.
lots of the robots? Like, I assume that that's quite a big thing.
It's actually relatively simple because it's not like we're bending metal. Someone else does all of that stuff. Like they build the sheet metal. So you do the all the CAD designs, you do all the drawings, you send it out to a shop, they fabricate it. And really what you're doing at a robotics company, if you're doing assembly, is you're doing assembly and test. Um, and not to say that we're not manufacturing, but we're not bending metal. And so
Yep.
the parts
You're
go
just
out to a
putting parts
shop.
together.
Yeah, we're putting them together and then calibrating them and then making sure that they turn on. And so it's actually relatively easy to build or assemble, let's call it robot hardware, especially in the case of the smaller robots. The larger robots get a lot more complicated because of the safety systems and things like that are required. But for our smaller robots, almost all the parts in the smaller robots are custom, and so we have a lot of control over it, and comes in, we put it together, and it works.
Gotcha. That's interesting. I've heard, so some companies that I've talked to, I've had a lot of difficulties like finding suppliers and working with it. And I've heard things like the CEO will fly every, or CTO, or some person in the company will fly every 3 months to, say, the Shenzhen area in China,
Yeah.
and work with them on the manufacturing. Did you guys have to do these kinds of things,
No.
or?
No, because
Huh,
we predominantly made everything in the United States, and anything that wasn't made in the United States, we had U.S. partners that handle all of that.
interesting.
Yeah,
Can you
so
speak a bit about that, the manufacturing in the US? Because I'm not honestly terribly aware of many robotics things being made in the US.
yeah, sure.
It's new info to me.
Yeah, so if you look at it, if you look at the Freight 100, our 100 kilogram platform, it has about 300 total parts, about 100 unique parts, and uh, the the um, the things that are made not in the United States are things like the laser scanner. That's made in Germany by SICK. The skins, those are injection molded in China, but they're designed in the United States. Actually, the molds are designed in the United States, and then they're built in China. And then our wheel motors are based off of a hub motor that you see in like scooters and stuff like that. And
Oh, that was clever. Yeah.
and we did all the engineering design in the United States with a company that we use. Their SEI motors. They make kind of custom motors. And then they own parts of factories in China. So in terms of the extent of the componentry that's like fabricated or made not in the United States, outside of the computer, let's call it, um, it's all made in the United States. So we design our own PCBs. Those are fabricated at a PCB fabrication place in actually California. All the sheet metal is bent in many. I mean, the Bay Area has a lot of manufacturing capabilities. And all of the sheet metal is, I mean, one of the sheet metal vendors is literally a block from our office. Uh, they they kind of scoot it down the road, you know.
Yeah.
And so all of that and the paint, you know, the any of the other things like uh, powder coating and stuff like that, it's all done locally. So
Wow.
if you look at it, unfortunately, the U.S. commerce defines defines made in the USA by cost of goods. So because we have a laser scanner that's made in Germany, we can't call the robot made in the USA. We can say it's designed in the United States, but if you look at it on a per uh, like
Because the laser scanner is such a large component of the
mhm,
whole robot's cost.
yes,
How
yeah,
much can you tell how much one of the robots costs?
no,
Okay.
no,
That's good.
sorry,
Like,
that's a
okay.
closely guarded secret.
Okay, okay.
Yeah, but the if you look at it from a total part count sense, the majority of the parts are made in the United States.
Hmm.
And so most of the labor and things like that and the jobs are being created in the United States. But there's this technical way of judging, um, you know,
If you can call it what you can call it. It makes sense. Although it'd be nice if it was by item rather
yeah,
than,
it would be really nice.
because honestly, before talking to you about this just now, I didn't realize robotics manufacture was done in the US to any real
Oh, there's
extent.
there's lots of companies that
Uh-huh.
do their fabrication and assembly in the United States. You'd be surprised.
I am.
Yeah.
Interesting. Okay, I want to learn more about that.
Yeah.
So now moving on to the next stage. So after 5 months or whatever it was, you were a
Yeah.
software company.
Yes, we
Can you
were.
tell me a bit about that?
Yeah, so that's building all the software for the robotics side and the server side. And so when we first started, um, we you know we kind of heavily modified the raw stack to support our needs. Eventually, we ended up um, basically kind of drawing the line where we were going to use the raw stack. So we use it basically for message passing and all the libraries and visualization. But we no longer base any of our navigation and SLAM on
Ah,
top of the raw stack.
yep.
Um,
So
uh,
would
but
that
go ahead.
change with Ross too, out of
No,
curiosity?
no,
No.
no. No, I think that you know we definitely are going to move to ROS 2 in the future. We're trying to figure out the right time to do it. Um, but the 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 ROS navigation stack is a research stack that really wasn't meant to scale for the type of applications that we're deploying it in today. And the same is true for kind of the SLAM algorithms. It doesn't say anything negative about the ROS navigation capabilities or anything like that. It's just not well suited for our applications.
Yeah, you said million square foot
Yeah,
warehouses. Like, I'm not terribly surprised that it doesn't scale to that.
yeah.
Okay.
Um, and then you know, then we also built the server side componentry. So this is stuff that I think now you're starting to see more attention to it in ROS with like ROS web tools, but but previously there wasn't as much focus on you know user interfaces, tool chains for editing and modifying the map and things like that. And so Fetch built all of that software stack, you
Yep.
know, for basically allowing users who know nothing about robots to use robots.
Yep. So they can have a nice interface, and the interface kind of
Yeah.
helps them use the application. Yeah, I think that's an important thing to add into Ross,
Yeah, Ross
the
is
Ross
missing
ecosystem.
this. Yeah, the Ross ecosystem is missing like this entire kind of dev tools
Yep.
robot chain.
Dev tool. What do you mean dev tool robot chain?
So like there's a lot of deployment tools for robots that are missing. Like there's no good open source packages for deploying software to lots of robots.
Ah,
There's no
yeah.
good open source tools for monitoring lots of robots concurrently.
Have you looked at, I don't know, I haven't used it. Have you tried Amazon Greengrass and
Is it
their
open
Robo?
source?
No. No.
Yeah.
Oh, you said no open source.
Yeah,
Yes.
no open source. Yes.
Ah,
Yeah. I mean, there's plenty of people who are willing to charge you money for these services, but
it's true. No
you
open
know,
source.
the thing that sparked all of the explosion in companies for robotics and using ROS was that there was no cost burden to get started. And so those are some of the tools that are missing from the community.
What would you say explicitly? I mean, I'm the Ross boss for the Humble 2
Yeah.
release in a year.
Hmm.
And so I'm interested in to see what, like we're still building the roadmap basically, but
I mean, if you ask my team today what they want, they just want documentation, like real documentation.
that's the biggest priority so far
Yeah.
for Humble. I
Yeah.
totally agree with you on that.
Yeah, and you're talking to the person who used to be the Ross Wiki czar. So, I
Back
mean,
in the day, yeah,
yeah. Well, all the tutorials I wrote are still the tutorials for Ross.
that's crazy. When were
All,
so
go ahead.
this the Willow Garage days or this is the
Yeah.
early Ross days?
Yeah, milestone three of Ross and Willow Garage was documentation. And
Okay.
during that time, I wrote about 200 Ross tutorials.
Gosh,
So all the base tutorials like
it's
you
still
see
all your
today,
work. That's
yeah,
crazy.
anything you see with like Turtle Sim, I probably
Yeah,
wrote.
that's so funny. And now in Ross 2, it's the same thing. They're just derived from the old ones.
Yeah.
So you probably like, oh, I remember writing that. That's so
Yeah,
funny.
Maria actually when she was converting him, like
Uh
asked me questions about him. She's like, "Your name's at the bottom of all these pages." And I was like,
huh.
"Yeah, because I wrote."
Uh-huh. And Maria is the former, she's no longer at Open Robotics,
Yeah.
but she was like the documentation lead for
Yeah.
the ROS 2 initiative, as far as I understand.
Yeah, and I think she ported a lot of the ROS 1 tutorials to ROS 2.
Mm-hmm. Definitely. Okay, so that's interesting. So you built your own nav stack, and then all the
Yeah.
server side, so you can control the robots.
Yeah.
Those are two things that are really not the nav stack, but the server side, and the building user interfaces, robot web tools, these kinds of
Yeah.
things. These would be good to see in ROS 2, you think, right?
Yeah, I think from an open source perspective, yes. I think the biggest challenge
And
is
deployment.
yeah, deployment, robot monitoring, but all of that, I
Yep,
mean, those are huge undertakings, and
it's true.
whether anyone's willing to fund it or support it, I mean, because many companies like Amazon are
They're green
building
grass.
closed sourced tool chains that, they want to get you hooked
Yeah.
on their platforms.
So did you guys build your own or do you use one of these? Oh, you
Yeah, we
did.
built I mean,
It was early too.
it was really early. I mean, In Orbit and Formant and what are the other six other guys that are all doing kind of those things? All started 2 or 3 years after Fetch started as a company.
Mm,
So
gotcha. You had to.
yeah, I mean it's why it's the same thing that a lot of people ask why Ross didn't base their communication layer off of
The,
protobuf. It didn't
yeah, yeah.
exist. It
Yep.
didn't exist when Ross started, and then DDS wasn't as mature a long time ago. So there's just
Yeah.
lots of questions. Like I think
Why not
people
this? And it's
sometimes,
like, yeah,
what what do you want? It didn't exist.
I know. It didn't exist. And we've been building on top of what we have this whole time.
Yeah.
Huh. Okay. And then any what were some of the hardest challenges I would say with the software company that you had for before becoming a data company?
Yeah, I mean,
So million foot square foot warehouse sounds really tough.
yeah, that was hard. I would actually say that many of the challenges that we ran into were with forklifts. I hate forklifts.
Yeah.
Getting safety right, that's really hard.
Yep.
Um, I think in general, helping to help customers understand what is capable and what is possible and what's not possible.
Just like what you were saying at the beginning with the tempering expectations,
Yeah.
this kind of thing.
Yeah, I mean, I you know, I think so. You know a fair bit about robotics, and you probably know that like the robot footprint really matters, right? Like as the robot travels through the world, it needs to know how big it is, right?
Hmm.
One of the most common asks from any customer is, "Can't we just?" And that's how it always starts. Um, can't we just overhang the footprint by an inch, or 3 inches, or 15 inches? And it's like, no, the
50.
robot doesn't know how big it is. The robot can't see those things. But that's one of the hardest things with kind of people's understanding or lack of understanding of robotics, and also their kind of expectations as they see it from really killer, videos like
Demos.
Boston Dynamics. I mean,
Theirs are amazing. Yeah.
yeah, they're super amazing, but I would love
Blows
for
up the
Boston
expectation.
Dynamics to upload the
Fail.
40,000 retakes before
Yeah.
they got the backflip to work that one time.
I couldn't
Um,
believe when that occurred. Like watching
yeah,
that video, I was like, oh my God, what is this? That's crazy. I was
yeah,
in a legged locomotion lab at the time,
yeah,
and it was
it's
like,
super crazy.
we're just getting our thing to walk. They're doing backflips.
Yeah,
Crazy.
but you and I both know as roboticists like
There's a
that
blooper reel.
there's a blooper reel and it's really long,
Huge.
right? Yeah,
Uh-huh.
and so one of the bigger things about software, as you know, is lots of things are possible, but the time to implement those things can be very long, and they
Hmm.
can be very weird. They can also contain very weird edge cases and things like that. If you were doing legged locomotion, then you definitely know how bad edge cases are.
Oh, it was very
Um,
spiky. The
yeah,
optimization space. It would like work great, fall down.
yeah,
It's like very, very tough to tune parameters. But yeah.
yeah. And so those I think are some of the bigger things that we ran into uh, over the time of building software, and just figuring out how to support some level of adaptability in the system or customization
Hmm.
without basically writing one-off code for every customer that ever wants anything.
Yes, totally. Yeah, that's hard because it's tough to make the software flexible in a good way. Like, I mean, it's good software design, but it's hard to predict. And it'll be like, oh, they want this little thing that's slightly different that requires a major assumption that the whole thing was built upon to be changed. So that can be painful and difficult. They're
Yeah,
like,
we.
I
Oh, go
just
ahead.
want this other little thing. It's like,
Yeah.
no, I cannot.
We went through this whole exercise for our cart connect, like, and we basically got to the biggest cart we could absolutely move around with this robot,
Hmm.
and like in the field, everyone's loving it, and then like about 6 months in, then we start getting the request, can't we just make it an inch bigger? And the answer was no. We made it as
Yeah.
big as we possibly can. Like there's
Yeah.
there's no more. you know?
How funny. 1 inch.
Yeah,
Can't we just? What a
yeah.
funny thing. You're like, oh no, oh
Every
no.
time I hear it, can't we just? Or would it be so hard if?
Yep.
Or I mean,
These
the
little, yeah,
the way
these
they
little
start
asks.
always.
Yep. So let's see. Okay, so we talked a little bit about the data before, and I'd love to learn a little bit because we're running out of
Oh,
time.
sorry about that.
No, it's all been very interesting, but I'd love to hear a little bit about the acquisition process
Yeah.
with Zebra. I know you're still going through it.
It just closed like in the
Just closed,
last
closed.
30 minutes. I mean, we announced it complete a couple of days ago, but
Yep.
the money came into the bank today.
Oh, congrats! What a breaking interview. It's just so. Can you talk a bit about the experience? I've heard
Yeah.
horror stories with acquisitions. If I understand correctly, they had say 5% or something stake in your company, and then they just bought the rest out. or
Yeah, I mean,
how's the
well, it was a
experience
full
been?
acquisition process. Like they had been a previous investor. We went through an acquisition process. We engaged with other potential acquirers. Um, but Zebra really seemed like the best fit for us. And one of the things that really got me excited about Zebra acquisition is in January, they actually hired Jim Lawton. He's been in the robotics industry for a while. He worked at Rethink Robotics. He worked at Universal Robots, and he'd done a variety of different startups, things like that. And he had a good reputation, and it signaled to me that they were very serious about robotics and robotics automation.
They've done their
And
homework. They made a good pick. They brought
yeah,
someone
and
who's
someone I
done good work in.
respected.
Yep.
Yeah, and when you look at it, as you said, there's always this fear of the acquisition going terrible, like someone buying your
Hmm.
company and then saying, you know what, we want to do home robots or something like that. I think that would have been soul crushing for me.
Yeah,
Um,
I
like
imagine.
like forget all of this stuff you've been working on for the last half decade or so. Why don't we just go work on vacuums? You
Yep.
know, and so the Zebra acquisition was really for me about finding a good fit. I mean, obviously, money is a factor, but making sure that the visions are aligned, the outcomes are well aligned, and I felt like Zebra was a good fit for us. If you look at some of the things that were happening before that, so after they invested in us, we started partnering on some things. And one of the cool things that we did about a year and a half ago is so they make hand scanners, so you can scan a barcode and it like tells you what this thing is, or it goes to a system and does something. We a year and a half ago made it easy to integrate their hand scanners with our robots. So like someone could scan a barcode and a robot would like automatically appear. And so
That's cool.
that was a super cool integration because if you look in manufacturing, some guy's building something, right? He's assembling something and maybe he runs out of screws or maybe he runs out of something. He can just scan a barcode and a robot with a cart shows up and says, "Here's your thing." And so that was very powerful for some of our customers, and they really liked it. And we've been slowly expanding our platform to integrate with like all the other industrial IoT devices out there. We actually created a partnership with SICK as well for this kind of application. And so we that was really cool. We had experience working with them. We knew it wasn't like the worst thing in the world. And it was easy to work with them, get things done, and we got things done. Because that's the other thing that you could run into is you get acquired and nothing happens. You do the quintessential rest invest. And
The what?
however, rest invest, it's a term that people throw around in
Hadn't heard it.
startups. After you get acquired,
You just
if you don't
coast.
like what the company's doing, or
Oh,
you
you're
don't
out.
like, you just no, or you stick around and you just rest and vest.
Ah,
um,
gotcha. Oh,
but
rest while
vesting the rest of
you're
your options
vesting.
or
Yep,
shares, yeah. I
gotcha.
mean, I have no
Because you
intention of
typically, yeah, you're not
doing
resting and
that.
vesting.
No, but I didn't. That was one of my goals. I didn't want to end up at a company where that was my main bag.
Oh,
Oh,
definitely.
yeah.
Okay. And then how did you so it's just interesting to me to find a good fit. It probably means that there were other companies that looked into buying you guys.
Yeah, I can't
Uh,
speak to the whole process in that regards, but yeah.
but I like that you found a good fit for this kind
Yeah,
of
I
thing
feel
then.
like we found a good fit.
Awesome. So with just a few minutes left, I was hoping for more time for this because you have an interesting perspective.
Hmm.
But what's the so if you're projecting like 5 or 10 years down the road, where do you think we're going to be with robotics? And you can speak to warehouses or anything else.
Not much further than we are today.
Really?
Yeah, I, you know, a couple years ago, actually at a ROSCON, the CEO of Ubuntu or Canonical got up and he said, the thing about success is it takes 10 years to have an overnight success.
Yeah.
And and robotics is a slow moving train. I think that a lot of people probably who know Fetch and who know me don't or may not have realized or remembered that we're a 7-year-old company, right? And
Hmm.
it's taken 7 years to get to this success point. And we haven't done a lot in that 7 years,
And you were also
but
involved in Willow and everything
yeah,
before that.
yeah.
So,
And so if you look at it from the time I came out here in 2007, it's been a
mhm.
long time, right? And it's not saying that incremental advancement won't happen over these 10 years. I just don't see us having like this big light switch moment in robotics. I mean, everything will kind of just incrementally trickle. But if you
Yep.
were to ask me about autonomous cars, I think we're 20 to 40 years out on autonomous cars.
Wow.
Oh,
Okay.
yeah. Like
That's
people who
awesome.
are saying that Tesla is going to be driving on the BS. I mean, anyone who says that needs to
Yeah.
go do it for a couple of years and figure out how hard the goddamn problem is.
Yeah, for sure.
um, and so I don't know. I mean, I think the one thing that I could see that could be game changing for indoor robotics in the next 10 years is the new wireless standards that are coming out for localization to
Hmm.
kind of solve this where is my robot problem. I think that could be really game changing if that technology takes off, like ultra wideband location or
Hmm.
the Wi-Fi 6 standard that includes local location information as part of the Wi-Fi like
Wow.
packet.
Huh.
Um, that's something that could be super game changing. I think it could have a wide sweeping effect in robotics because now really then the problem comes down to how good can your navigation be, not where the hell are you all the time.
Yeah, it's
um,
true.
I think that we'll see good improvement in bipedal locomotion robots. I don't think
Hmm.
we'll get to anything really practical out there in the world. I mean, you worked on it, you know how spiky it is, let's call it.
It's true.
I think that one thing we might see, though, from the autonomous car space, which I'm kind of interested in seeing, is I think that players like Neuro and those smaller uh, um, local distribution autonomy vehicles that are more like little smart cars
Ah,
with delivery baskets in them on the roadways could be game changing. But it's not full autonomy and it's kind of, side streets, not highway driving for delivery of groceries and things like that. I think there's promise there. And I think that might be something we might be able to deliver on inside of 10 years because the complexity of the autonomy is localized
yep.
and limited.
Do you think, do we get further with like human robot hybrid models where a human takes control if the robot gets into a situation it doesn't have high confidence about navigating?
Absolutely. We're already doing that today. The question is how far can we push the safety boundaries of that? So far, it's not clear that we have much of a good, clear idea of what that means. But like, if you have a truck that's being driven remotely by a person and the Wi-Fi cuts out or the signal cuts
I
out,
know, terrifying. Yeah.
yeah, terrifying. Keywords, terrifying.
Yep.
Now, if you look at Fetch and Plus One and lots of other companies, we all have remote monitoring in some way to assist the robots, but we greatly rely on autonomy. It's like 99.5% autonomy, 0.5% human. I don't know where if that'll start spectrum wise going more towards the 90%, but it's hard to provide um, return on investment with a lot of human in the loop autonomy because of just the
People are
time
expensive too.
and time too, like
Ah,
time to accomplish it, like time to recover.
oh, I see. Gotcha. Okay, so let's see, wrapping up, do you have any public, like social media or company blog or anything that you'd like to share with our listeners if they'd like to learn
Uh,
more or get in
sure.
touch?
If people want to learn more, I mean, the biggest thing they just need to know is how to spell my name. It's Melonee. I'm very unique. I have great SEO. So I have a Twitter that's just Melonee Wise. Everything is just Melonee Wise. So if you Google Melonee Wise, you'll find my Instagram, my Twitter, my LinkedIn, all of that very easily. I will say some of my channels are pretty fragmented. Some of them are only personal stuff. So if you go to my Instagram, there's no robots there. It really is just beer and travel.
Good to see
That's
you're
me.
human too. Yeah. Okay. Is that it for
Yeah,
those?
sure, definitely.
Okay. Well, I've enjoyed speaking with you. Thank you.
Yeah, it's been great. Thank you very much. I appreciate your time.
That's all we have for you today. If you enjoyed this interview, consider subscribing. To comment on this interview or to give us general feedback, especially while we're just getting started, go to sensethinkact.com, or you can find us on the Ross Discourse. We'll be back in 2 weeks' time. Goodbye, everyone.